Hi everyone, welcome to ACE. I am Mallikarjun. Here I am going to discuss few important questions for RRB JE exam. Subject is structural analysis. Students, structural analysis or theory of structure, both are same only. Okay, so but in your syllabus you mention theory of structure. Okay, so first we will see the syllabus once, right. So this is the syllabus given in RRB JE exam. Mechanics of structure, this is the strength of material subject, okay, and here given theory of structure. So this is structural analysis. Sir, you will discuss only theory of structure, then why you are showing here strength of material, sir? Students, in strength of material given analysis of trusses, okay, and strain energy. Strength of material and structure analysis both are almost same only, right? Difference is in strength of material you will do analysis for statically determinate structures, but in structural analysis nothing but theory of structure will do analysis for indeterminate structures. Okay, the students, these two topics will discuss in theory of structure only, not in strength of material. But you will see few concepts of strain energy in strength of material subject also, but few additional concepts required. Those additional concepts you will see in theory of structure. Okay, then I will shift this analysis of trusses into theory of structure. Okay, and here in theory of structure given direct and bending stresses, this is not structural analysis, again this is strength of material subject. Okay, slopes and deflection also strength of material subject. Okay, fixed beam, yes, we will discuss in structural analysis only. Okay, and the continuous beam, yes, structural analysis, and analysis of continuous beam by using moment distribution method given. Yes, only one method mentioned in the syllabus, that is moment distribution method. Okay, and here given columns. So these columns, it is not structural analysis, again it is strength of material. Okay, so what are the topics I am going to discuss? Okay, in theory of structure, that is analysis of trusses, few concepts of strain energy, okay, that is energy principles, and fixed beams, continuous beams by using moment distribution method. Okay, if you see the previous RRB JE exam question paper, okay, questions are very basics, simple questions only asking. Don't break your head, okay, just learn the concept, that's it. Here I am going to show few important questions, basic concepts only. I am not saying in examination they will ask the question from these questions only, no students. Okay, this type of models may be possible of asking in RRB JE exam. Okay, right. So here first question, right. Simply supported beam with internal hinge at the midspan is. So this is the simply supported beam, right? Okay, but in the question given simply supported beam with a hinge. Right, so simply supported beam with internal hinge. Okay, right. If it is subjected to some external load, how this beam will deflect? It will deflect like this, right? Okay, then if you apply load over this beam, then it will deflect like this. Okay, so in this case this deflected profile is linear. Okay, but in this case deflected profile, is it linear? No, it is non-linear. Students, If the deflected profile is linear, it is called mechanism, and the mechanism also called unstable structure. Okay. Now student, simply supported beam is stable. It means after removing external load, this deflected profile goes to its original position, then it is called stable. But in this diagram, after removing load, this deflected profile, it won't goes to its original position, then it is called unstable structure. Unstable also called mechanism. So this is unstable, also called mechanism. Okay. So what is given? Simply supported beam with internal hinge is unstable, right? Then option C is correct. Okay, right. Now we'll see the next question. At a rigid joint in frame, all the members have. Students, practically how to get the rigid joint? If the members are connected with more than one bolt or welding gives rigid joint, right? Okay. Then here this is the beam and this is a column, right? Okay. So beam and column connection, this is called a rigid joint, and this is also a rigid joint. Okay. Before loading, what is the included angle between the members? 90 degrees, right? At both the joints. For example, this is A, B, C, D. Okay. Here A and D are fixed supports, B and C are rigid joints. Okay. Initially there is no external load, then included angle between the members, it is 90 degrees, right? Not always 90 degrees, it may be more than 90 degrees or less than 90 degrees. But in this diagram, included angle between the members at joint B, at joint C is 90 degrees before loading. Okay. Now we will apply some load. Due to application of load, if it is apply loading is symmetric, it means if we apply the load exactly at the center, that is symmetry, then this frame will deflect like this. At the fixed support, slope is 0, fixed support slope is 0, then it will deflect like this, right? Yes, it will deflect like this. So this is called deflected curve, also called elastic curve, right? Now this is the rigid joint B, rigid joint C, right? This is the rotation clockwise, and this is also rotation clockwise, right? Okay. Then here rotation is anti-clockwise, here also rotation is anti-clockwise. Students, I told one point, at the rigid joint, rotation in all the members are always same and in same direction. Same direction means at joint B, this rotation is clockwise, this rotation also clockwise, right? It means at joint B, rotation of beam, rotation of column are in same direction. Similarly, at joint C, rotation of beam is anti-clockwise, rotation of column also anti-clockwise. It means at the rigid joint, rotation of beam, rotation of column are in same direction. Okay. Then students, always if the beam rotate by an angle theta B, column also rotate by an angle theta B. If the beam rotate by an angle theta C, then column also rotate by an angle theta C. It means at the rigid joint, rotation, what the members are meeting at joint B, rotation in all the members are same only and in same direction. Okay. It means after loading also, included angle between the members, it is 90 degrees only. Okay. Because rotation of beam, rotation of column, same amount, right? Then included angle between the members remains same. So before loading 90 degrees, after loading also it is 90 degrees only at the rigid joint. Okay. Then if you apply the load, unsymmetrical. If it is unsymmetrical, for example, so it will deflect like this. Okay, so this is the joint B, this is the joint C. Okay, before loading joint B is here, after loading joint B is here. Okay, now this is the C, now this is the C dash. The students, this is the horizontal displacement of column, this is delta B and this is delta C. So this delta is nothing but sway, right? Okay, delta is nothing but sway. Then students, delta B equals to delta C always. Practically it is not same, but this difference is negligible. Okay, and we are assuming delta B equals to delta C. It means sway in left column equals to sway in right column. Okay, so what is given? Same rotation, yes, same rotation, but different displacement? No, same displacements, right? So these are displacements and these are rotations. Rotation also called slope, right? Okay, so option A is wrong. Then same displacement but different rotation, no. Okay, different displacement, no. Same displacement and rotation, then option D is correct at the rigid joint. Okay, right. Now we'll see next question. Number of independent equations to be satisfied for static equilibrium in a space structure. Students, I given a topic heading equilibrium equation of a structure, right? Okay, for pin jointed plane frame, for structure, number of equilibrium equations are 3. For pin jointed space frame, number of equilibrium equations are 6. For rigid jointed plane frame, number of equilibrium equations are 3. And for rigid jointed space frame, number of equilibrium equations are 6. Okay, so given space, right, then number of equilibrium equations are 6. Okay. Yes, very good. Next question. Comparability conditions satisfy. Students, I told in structural analysis subject and complete each and every chapter depend upon equilibrium equations and comparability conditions, right? In each and every chapter we'll use equilibrium equations and comparability conditions. I given definition of equilibrium equation, balancing of forces and moments. And what is the definition of comparability conditions or comparability equations? Balancing of displacement. It means equilibrium equations deals with forces and moments. Comparability conditions deals with balancing of displacement. I told displacement means it may be deflection or rotation. Okay, so given displacement conditions, then option B is correct. Okay. Yes. Now next question. Which of the following makes statically determinate beams? Students, I given few examples for statically determinate structures and indeterminate structures, right? First, what is the definition of statically determinate structure? If the number of unknown forces equals to number of equilibrium equations. It means if equilibrium equations are sufficient, it is called statically determinate structure. If equilibrium equations are not sufficient, then it is called statically indeterminate structure, right? And indeterminate structure also called redundant structure or hyperstatic structure. But here given statically determinate structure. What are the examples are given for statically determinate structure? Simply supported beam, cantilever beam, double or single overhanging beam, 3-hinged arch, etc. Okay, so what is given? Simply supported beam, yes, determinate structure. Cantilever beam, Yes, determinate structure. And overhanging beam, it may be single overhanging beam or double overhanging beam, determinate structure. Okay, yes, then option A is correct. Okay, and fixed beams, is it a statically determinate structure? No, indeterminate structure, right? So what are the examples for statically indeterminate structures? Fixed beam, propped cantilever beam, continuous beam, two hinged arch, fixed arch, etc. Okay, right. Next question. The static indeterminacy of a beam fixed at one end and hinged at other end is equals to, he asking to find the static indeterminacy. Okay, so what is the formula to find the static indeterminacy, students? General formula, ds equals to dse plus dsi, right? Then I told for beams, okay, clearly mentioned, right? Here it is mentioned beam. For beams, always dsi is 0 only, right? Okay, then what is the formula to find the dse? It is r minus s only, where r is number of reactions and where s is number of equilibrium equation. Okay, I told while finding the static indeterminacy for beams, I told one note point, careful. What is the note point I given? If the member is flat, subjected to purely vertical load, always neglect horizontal reaction and horizontal equilibrium equation. Okay, for general loading for beams, by default equilibrium equations are 3. Okay, right. So here final formula ds equals to r minus s. This is for beams. Okay. Yes, we'll check it. Tarun. Right, what is given? Fixed at one end, okay, and hinged at another end. Now can you find the static indeterminacy for this? Just this is the general loading, right? Okay, for fixed support, number of reactions are 3. For hinged support, number of reactions are 2. Okay, then ds equals to 5 and equilibrium equations always 3 only, right? Then equals to 2. Then option B is correct. Okay, yes. Next question. Can you tell the answer for this question? Static indeterminacy for the continuous beam shown in below. So this is the continuous beam. Okay, is it a general loading or purely vertical loading? This is general loading only, right? Okay, for fixed support, number of reactions are 3. Roller support, number of reactions are 1. It is vertical. Then this is also roller support. This is inclined, right? And reaction also inclined, only 1 reaction. Okay, then total number of reactions are again beam only, right? Directly we can use the formula r minus s only. Okay, so total it is 5 and equilibrium equations 3 equals to 2. Again answer C is correct. Okay, right. Very simple questions. Next, relation between number of joints J and number of members M in pin jointed plane frame. Okay, determinate truss. Students, if M equals to 2J minus 3, these are the number of members and these are the number of equilibrium equations. Okay, if the number of unknowns equals to number of equilibrium equations, then you will get dsi equals to 0 only, right? Yes or no? This is a formula given, right? dsi equals to m minus 2j minus 3, right? When you will get dsi equals to 0, if this value equals to this, then only you will get the dsi value equals to 0. That is called internally determinate structure. Okay, so given determinate truss, that is option A is correct. M equals to 2j minus 3, not option A, Option B is correct. Okay, M equals to 2j minus 3. So I am expecting more number of questions from trusses, analysis of trusses and movement distribution method. Right. Next, the number of members in a frame is 10. M equals to 10. Okay, and the joints given, it is 9, and it is an example of. Students, if M equals to 2j minus 3, this is called perfect frame, right? Okay, if M greater than 2j minus 3, this is called redundant frame. Okay, then if M less than 2j minus 3, this is called unstable, right? So unstable also called deficient frame, also called mechanism. Okay, unstable, deficient or mechanism, 3 are same only. Now check it which condition is satisfying here. Okay, first 2j minus 3. So here 9 minus 3 equals to 15, right? Yes or no? So here number of members are 10. Okay, then this is M less than 2j minus 3. If M less than 2j minus 3, it is called deficient frame, unstable or mechanism. Then option B is correct. Yes, Hamad, correct. Okay. Now next question. The degree of static indeterminacy of a rigid jointed space frame. I given a simplified formulas. Okay, what the simplified formulas I given? For pin jointed plane frame. What is the DS formula? M plus R minus 2j, right? Okay, and second, for pin jointed space frame, then ds equals to m plus r minus 3j, right? Okay, then similarly for rigid jointed plane frame, what is the formula? This is 3m plus r minus 3j, right? Okay, then for rigid jointed space frame, what is the DSI formula? Sorry, DS formula 6m plus r minus 6j, right? So these are the simplified formulas I given. Okay, check it. He asking rigid jointed space frame. For rigid jointed space frame, 6m plus r minus 6j. Okay, 6m plus r minus 6j. Then option D is correct. Yes, correct, students. Right. Then next question. The basic perfect truss is A. Students, what is the perfect shape of the truss? If you see any industrial building, this triangular shape only, right? Yes or no? The perfect shape of the truss is triangle. Okay, if there is a missing of triangle, then it will become unstable structure, right? Okay, that is internally unstable. Okay, so the perfect shape of the truss is always triangle. Then option A is correct. Yes, Karthik. Right. Next, all the loads in a plane truss are applied at. Can anyone tell this one? The other points are given in analysis of trusses, right? Yes, very good. The option B. In analysis of trusses, I given assumptions. What the first assumption I given? Okay, truss members are subjected to only axial forces, right? That is axial compression or tension. Okay, practically there is a shear force and bending moment also. But compared to axial force, shear force and bending moments are negligible. We are neglecting the shear force and bending moment. We are assuming truss members are subjected to only axial compression or axial tension. This is the first assumption I given. And second assumption I given, load should act only at the joints, right? Yes or no? If load will act on the member, that member will bend, then there is a bending moment in the member. But we assume truss members are subjected to only axial forces. And third assumption is given, members must be straight only, right, in trusses. Okay, so like this I given a total 5 to 6 assumptions. Okay, so here always load should act only at the joints, not on the member. This is the assumption. Okay, right. Next question. Pin jointed simple truss is shown in figure, okay, in which the zero force members are. Now can anyone tell the answer for this? I given few shortcuts to identify the zero force members, right? I given heading hints to determine the zero force members. I given 2 shortcuts. First shortcut I given for 3 members. Second shortcut I given for 2 members, right? What is the first shortcut for 3 members? At the pin joint, if the number of members are 3, out of 3, 2 must be collinear. Then only force in third member is 0, right? And I told one point, always loads and reactions we have to treat as a members only, right? Okay, after treating load and reaction as a member, at that particular joint, number of members should be 3 only. If the number of members are more than 3, then shortcut is not valid, right? Okay, and what the second shortcut? Second shortcut only for 2 members, right? Okay, look at here. First shortcut, this is the given. At the pin joint, number of members are meeting 3. Out of 3, these 2 are collinear, in nothing but same line, then force in third member is 0. Okay, then second shortcut I given, at the pin joint, if the number of members are only 2, okay, at the pin joint, if the number of members are only 2, okay, and these 2 are in same line or different line? Different line, then force in both the members are 0. Okay, and I given few more shortcuts like this. This is the roller support. Okay, if there is a vertical reaction here, and this reaction if it is not 0, this reaction treat as a member, and these 2 are collinear, force in third member is 0. In case this vertical reaction is 0, okay, for the same support, if the vertical reaction is 0, then don't consider 0 reactions, right? Don't count this as a member. Then how many members? 1, 2, and these 2 are different line, force in both the members are 0. Now apply these shortcuts here. B. Rajavardhan. Right, we'll check it. At joint A, how many members are meeting? Only 2 members, right? And these 2 are same line or different line? Different line. This is the second shortcut, right? Then force in both the members are 0. Okay, just we'll remove the 0 force members. But practically, we never remove the 0 force members, right? For stability purpose. Okay, but theoretically, we can remove these 0 force members. Okay, students, after removing 0 force members, here there is a vertical reaction RE, okay, and this is not roller support, this is the hinged support only. If it is roller support, then it will become unstable structure, okay. So this is not roller, this is hinged support. Then here number of reactions are 2. So this is left side, right, then this is right side, and here there is a reaction RD. Students, here vertical reactions, you will get some value, it is not 0. You will get some values, because this load will develop the moment at any one of the support, right. then here vertical reactions are not 0. Okay, right. The students, this reaction is not 0, right? This is treated as a member. Then after removing these 0 force members, at joint E, how many members are meeting? 1, 2, 3. Out of 3, these 2 are collinear, then force in third member is 0. Okay, next, at joint C, how many members are meeting? 2. These 2 are same line or different line? Different line. Second shortcut, then force in both the members are 0. Okay, then how many 0 force members? 1, 2, 3, 4, 5 members. Okay, given here, right? So, AB 0, AE 0. Yes, AB 0. Okay, yes, AB, AB. So, in option B, there is a no AB, right? Then eliminate option B. Next, AE also 0, right? So, here D is there, here AE is there, right? Then option C is correct. Okay, AB and AE. So, BC is it 0? Yes, BC 0. And CD is it 0? Yes, CD also 0. Okay. But here given only 4 members. But actually total 5 members are 0 here. Okay. Right. Next question. Can anyone tell the answer for this? Very simple questions. The forces in the various members of a perfect frame are. Find out from. Students, to analyze the trusses, I given basically we have 2 methods. One is analytical method, another one is graphical method. What is the analytical method? Method of joint, method of section is the analytical method. Okay, it means you can use method of joint, method of section or graphical method to find the force in the truss members. Okay, so method of joint, method of section, yes, graphical method, any one of the above, then option D is correct. Okay, yes, correct, Hamad. Right, next question. Method of joint is applicable only when the number of unknown forces at the joint under consideration is not more than. Students, I given an equilibrium equation of a structure, equilibrium equation of a joint, right? Okay, for pin jointed plane frame, for structure 3 number of equilibrium equation, but for joint only 2 number of equilibrium equations, right? In method of joint, we have to balance the joint, right? Then to balance the joint, we have to use equilibrium equation of a joint. It means number of equilibrium equations are 2. Now tell me, using these 2 equilibrium equations, what are the 2 equilibrium equations? Sigma H and sigma V, right? Equilibrium equation of a joint for pin jointed plane frame, number of equilibrium equations are 2. Okay, what is the use of equilibrium equations? To find the unknown forces values, right? Okay, so here 2 equilibrium equations are available. Using 2 equilibrium equations, we can find only 2 unknowns at a time, right? Yes, but in method of section, 3 equilibrium equations are available, that is sigma H equals to 0, sigma V equals to 0 and sigma M equals to 0. Then we can find 3 unknowns at a time in method of section. But in method of joint, we can find only 2 unknowns at a time. Okay, it means not more than 2, then option B is correct. Okay, yes, Hamad, correct. Right, next. So this is the question from strain energy, okay, but in structural analysis is a given name energy principles. So strain energy, energy principle both are same only. Okay, so this topic you will learn in strength of matter subject and structural analysis also. Okay, right, what is given? The strain energy stored in member AB, this is a member AB of the pin jointed truss in point D, there is a load P shown below and then A and E are A and E. This is the area and this is the Young's modulus are same for all the members. He is asking to find the strain energy. Students, what is the strain energy formula due to axial force? Strain energy, total strain energy given formula like this, right? Summation of P square L by 2AE, this is the total strain energy. But he is asking to find the strain energy only in one member, right? That is in member AB. Okay, that is force in member AB, length of member AB by 2AE. This is the formula, right? Strain energy formula. Okay, right. Only thing is we have to find the force in member AB. Again, to find the force in member AB, you can use the shortcut if it is possible. Okay, but in examination always will prefer shortcuts. If shortcuts are not possible, then next priority method of section, then later method of joint. Okay, right. First we'll try with shortcut. This is a roller support. Only one reaction will develop, right? This is horizontal reaction. Yes, this is the reaction HB. Then do one thing. This reaction just treat as a member. This is treat as a member. Now tell me, how many members are meeting at joint B? 3 members, right? 1, 2, 3. Out of 3, these 2 are collinear, right? Nothing but same line. Then force in third member is 0. This is the shortcut, right? Okay. Then students, if force in member AB is 0, then what is the strain energy here? So strain energy in member AB also 0. Okay. Then option C is correct. Yes. Next. What is the formula? Strain energy due to bending or flexure. Given strain energy of a structure due to bending. What is the formula? Integration of 0 to L mx square by 2EI dx, right? This is the formula given, right? Okay, where mx is nothing but bending moment at a section. Okay, so here there is a no 2, eliminate it. Here 2 is given above, eliminate it. Here given a 3, eliminate it. Then option B is correct. Okay, so m square dx by 2EI. Yes, option B is correct. Yes, very good. Right, next question. Strain energy stored in a simply supported beam of length L, flexurality EI due to a central concentrated load W. Clearly mention simply supported beam. Okay, so simply supported beam subjected to point load at the center. This is W. For example, this is L by 2, this is L by 2. Now can you tell the strain energy formula? Students, from strain energy, I am expecting questions. Okay, from strain energy chapter. And what is the strain energy in the trusses? I given an example, that is P square L by 2 AE. And strain energy due to bending, that formula is given, only formulas. Okay, and next we have standard derived values, right? Cantilever beam subjected to movement at the free end. Cantilever beam subjected to point load at the free end. Cantilever beam subjected to UDL. And simply supported beam subjected to point load at the center, and simply supported beam subjected to UDL. I given these 5 standard derived formulas, right? Already I derived these formulas, but I told for examination try to remember the standard values directly, right? Okay, now tell me what is the formula here? Simply supported beam subjected to point load at the center. Can anyone say? So strain energy for member AB, this is W square L cube by 96 EI we got, right? Already we derived this formula. Okay, and a few more formulas are given like this. Cantilever beam subjected to movement at the free end. and a cantilever beam subjected to point out at the free end, and a cantilever beam subjected to UDL over the entire span, and a simply supported beam subjected to UDL over the entire span. Okay, so try to mug up the standard formulas for these beams also. Okay, right. Next question. In the displacement method of structural analysis, the basics unknowns are. Students, in basics methods of structural analysis chapter, I given force method and displacement method, right? Okay, so in force method also called compatibility method I given, and displacement method also called equilibrium method I given. Okay, and in force method, forces are treated as unknowns. In displacement method, displacements are treated as unknowns. And what are the methods falls under category of displacement method? First I given moment distribution method, slope deflection method, Canis method also called rotation contribution method, and stiffness matrix method. So these are the methods falls under displacement method. And what are the methods falls under force method? Rest of methods, that is a flexibility matrix method, conjugate beam method, okay, and I given Castiglione's method, column analogy method, consistent deformation method, elastic center method. So these are the methods falls under force method. Okay, so what is given in displacement method? What are the unknowns? Displacements are unknowns. So option B is correct. Yes, Karthik, correct. Right. Next. And this is the question from movement distribution method. And students, in the syllabus, only one method clearly mentioned, that is movement distribution method. Okay, so concentrate more on movement distribution method. Compulsory questions in movement distribution method and analysis of trusses I am expecting. Okay, and more number of questions I am expecting from movement distribution method only. Only basics definitions. Don't do lengthy analysis. Balance carrier, no, not required. Just I given few definitions, right? Just learn the definitions sufficient to clear the RRB JE exam. Okay, right. If M is the external moment which rotates the near end, okay, of a prismatic beam without a translation, okay, the far end being is fixed support. So this is the far end is fixed support given. Okay, so this is the near end and it is subjected to moment M. And asking then movement induced at the far end. What is the movement at the far end? Okay, students, I told if the applied movement is clockwise, okay, if the applied movement is clockwise at support A, rotation also clockwise at support A only, right? Then to get the clockwise rotation at A, should I draw deflected curve above or below? You have to draw deflected curve below. Then only you will get the rotation is clockwise, right? So movement is clockwise, rotation also clockwise. And what is the slope at the fixed support? Always 0. Now this is the deflected curve. Okay, not toward the support B, rotation is anti-clockwise. But movement reaction always makes slope 0, right? It means we have to mark the direction of movement opposite to the direction. So this is called carrier movement, right? Yes or no? Okay, students, if there is no external load on the beam, then carrier movement equals to final movement only, right? Okay, now tell me, if far end is fixed support, how much movement will carry over? Always half of the movement will carry over, right? Same direction or opposite direction? Same direction. Okay, so this is clockwise. Yes, half of the movement will carry over. It means this is m by 2. Okay, so what is the movement at the far end? It is m by 2, same direction, clockwise. Okay, if the applied movement is clockwise, carrier movement also clockwise. If the applied movement is anti-clockwise, carrier movement also anti-clockwise. It means both are same direction. Okay, now check it. M by 2 in the same direction as M. Yes, m by 2 same direction as m, then option A is correct. Sir, can you please share class notes for RRB JE? Okay, don't worry, I'll help you. At the end I'll tell you, okay? Hi math. Right. So m by 2 in opposite direction as m? No. And is it m? 0? No. So we got m by 2 same direction, then option A is correct. Right. Next question. Propped cantilever beam AB fixed at B is subjected to the action of couple of moment at A, at the end A. What is the value of reactive moment at B which will be induced at the built-in end? Nothing but this is the fixed support. So given, for example, this is B, this is A. Now same question, similar question. So there is a moment at this is the moment MA, this is the fixed support. Okay, then what is the moment at B? Just now given. If R and is fixed support, half of the moment will carry your same direction, right? Clockwise, clockwise. So here MB equals to this half moment, right? Then MA by 2. Okay, so here what is the answer? But he asking MB, right? Then from this MB equals to MA by 2, right? No, something is missing here. Yes, MA by 2, then option D is correct. Okay, right. Next, the carrier factor in a prismatic member whose far end is hinged support. Okay, students, if far end is fixed support, okay, if far end is hinged support, these formulas are very, very important. Okay, what are you asking? Carrier factor, right? Students, carrier factor equals to far end moment and near end moment, right? Ratio of far end moment by near end moment. Okay, he given far end is hinged support. If far end is hinged support, what is the carrier moment? It is 0, right? Because hinged support cannot resist a moment, right? What is the moment at the hinged support? Always 0 only. Okay, then carrier moment is, that is far end is 0, right? Far end moment is 0, then what is the carrier factor? It is 0 only. Okay, then option A is correct. If it is a fixed support, just now told, if far end is fixed support, half of the moment will carry over, right? Then it is m by 2. Then what is the carrier factor? Far end moment is m by 2 and near end moment is m. This is 1 by 2. Okay, when it is m by 2, if far end is fixed support, but in the question clearly mentioned, if far end is hinged support, then carrier factor is 0 only. Okay, right. Next question. The moment required to rotate the near end of a prismatic beam through a unit angle without translation, the far end being is simply supported, okay, is given by where EI is fragility and L is the span. So what is given? Same, far end is simply supported. Now this is the far end, okay. I repeat, moment required to rotate the near end. How much moment required? This is near end, okay, of unit angle. So it will deflect like this, right? Okay, this is support A, then theta A equals to 1. Now tell me students, if far end is simply support or hinged support, how much moment required to get the unit rotation? This is a standard formula, right? So 3 EI by L. If far end is fixed support, moment required is 4 EI by L, right? This is the stiffness factor. Okay, then option A is correct, 3 EI by L. Yes. Right. Next question. In moment distribution method, the sum of distribution factor for all the members meeting at a joint is always. Students, are given distribution factor at a joint always 1 only, right? Yes. Okay, distribution factor, this is the relative stiffness by total stiffness, right? This is always 1 only at a joint. Then option C is correct. Yes. Next. At a joint of a frame, 4 members have joined. How many members? Yes, 4 members joined. And 3 members have distribution factor for here, for example, for this member 0.21 distribution factor, and for this member 0.29, and for this member 0.35. Okay, and what is the value of distribution factor for 4th member? Just now given. For example, this is A, B, C, D, E. Okay, just now given distribution factor at a joint always equals to 1, right? Okay, then distribution factor for member AB plus distribution factor for member AC plus distribution factor for member AD plus distribution factor for member AE equals to 1. So, in the question, it clearly mentioned for member AB, this is given 0.29, for member AC, for example, 0.21, and for member AE given 0.35. And he asking to find for 4th member. Yes or no? So, distribution factor equals to 1, right, at a joint. Then from this, can you find the distribution factor for member AD for 4th member? So, 1 minus 0.29 minus 0.21 minus 0.35. Okay. So, what is the value? This is a 2953, then it is a 0.15. Okay, yes, 0.15. Then option B is correct. Yes, students, you are correct. Okay, right. Next question. So, this is the topic fixed beams. In the syllabus, clearly mentioned fixed beams. So, we have standard formulas, right? Fixed end moments are given heading in moment distribution method chapter. So, fixed end moment, that is MAB for the given beam is. Okay, students, I told this applied moment at the center, right? This is symmetry, right? Okay, then the applied moment is clockwise, fixed end moment at AB clockwise and BA clockwise, right? Yes or no? Now, what is the formula? Standard formula. Fixed end moment for member AB, fixed end moment for member BA. A given sign convention, clockwise movement is positive, anti-clockwise movement is negative, right? Now, this is clockwise, positive, this is also clockwise, positive. What is the formula given? If it is at the center, formula is m by 4 only, right? Okay, then option A is correct. Yes, students, correct. Right. Next. So, this is also same fixed end moment at A of beam. So, you are asking to find the fixed end moment for member AB. Okay. So, this is WL square by 30 right here, and fixed end moment for member BA, this is WL square by 20 right formula. Okay. So, you are asking at the end A WL square by 30. Okay. Then option A is correct. Yes, students. Right. Next, what is the value of bending moment at the built-in ends, nothing but fixed supports, prismatic beam of length L carrying a single concentrated load P at the middle. So, fixed beam subjected to point load at the center, then what is the moment at both the supports? Okay, what is the formula given? This is PL by 8, right? Fixed end moments, PL by 8. Then option B is correct. Yes, correct. Raman Haimat. Right. Now, next question. If the sinking of support of a fixed beam cause the beam to rotate in clockwise direction, beam to rotate in clockwise direction, then the moments induced at both ends of beam will be, but clearly mention causes beam to rotate in clockwise direction. It means, students, if the right support is settles down like this, then rotation is clockwise, rotation is clockwise. Okay, then direction of movement opposite, right? Opposite to the rotation. Okay, so what is given? So both are anti-clockwise direction only, right? At A and B. So in anti-clockwise direction and of equal magnitude, yes. If both supports are fixed support, what is the sinking moment? 6EI delta by L square. Now this is the delta, right? Now this is also 6EI delta by L square. So same direction, same magnitude. Okay. So here in anti-clockwise direction and of equal magnitude, then option A is correct. So is it clockwise direction? Yo, both are anti-clockwise direction. Okay. Then option A is correct. Right. I think next. If one end of prismatic beam AB of length L with fragility EI with fixed ends, okay, and transverse displacement delta without any rotation, then the transverse reaction at A and B due to displacement. Okay, so if one end of prismatic beam AB, yes, this is AB, length L with fragility EI with fixed ends, yes, fixed ends, given a transverse displacement delta, nothing but sinking without rotation. Okay, then the transverse reactions at A and B due to displacement. So just now given, rotation is clockwise, moment reaction is anti-clockwise, rotation is clockwise, moment reaction is anti-clockwise. So both supports are fixed support, 6EI delta by L square, 6EI delta by L square. But asking transverse reaction, nothing but vertical reactions. Students, these two movements are in anti-clockwise direction only, right? Then reaction must be clockwise. So this is RA upward, then this is RB downward, right? Then how to find these reactions? Just add these two moments and divide it by distance. If you add this 6 plus 6, 12 divided by L, L cube. So this is 12EI delta by L cube, 12EI delta by L cube. Okay, so then option D is correct. Okay, right. Next question. Right. If far end of cantilever beam, fragility EI undergoes a unit displacement without rotation. Okay, unit displacement without rotation, bending moment at the fixed support. Students, cantilever beam is mentioned, but given far end without rotation, it means this is given indirectly fixed support. Okay, if it is fixed support, then only it won't rotate, right? Now slope is 0 at the fixed support. Then he asking, what is the moment at both the supports? Just now given, if both supports are fixed support, 6EI delta by L square, 6EI delta by L square. Okay, then option. But what is given? Delta is 1, right? Unit displacement. This delta equals to 1. If delta equals to 1, then 6 EI by L square, then option C is correct. So these are the basis questions. Okay. So students, don't expect directly these questions only will ask in RRB JE, please. Okay. So just I given few important questions here. Okay. So time up, right? So I can't discuss more. Okay. So students, if you want any notes, this is my mail ID. Okay, right. So, but concentrate only on basics concepts. Okay, don't go much depth, and especially in structure analysis subject. Okay, so students, if you have any doubts, you can ask me. Right. Anyway, students, thank you. All the best for your examination. Okay. Thank you once again. Just a minute.